All right, so we are starting the second part of inverse functions. We're going to go in a little bit more detail. It's actually going to feel a little bit more like kind of what we did last time. Okay, so here we have a table. We have functions f and g, and we're saying they're functions because if you look at the inputs, so -3, -2, -1, 0, 1, 2, 3, right? Those are the values of x. If I kind of just think of these, hang on, I'm gonna use a little highlighter. I'm going to go green for this guy. I'm going to go blue for this guy. Okay. If I kind of look at these and just treat like each one of these as their own y column, if you look at f of x, -3, 9, -2, 2, -1, 6, 0, -4, 1, -5, 2, -8, 3, -9, right? For each input, there's exactly one output. And you can say the same thing for g of x, okay? Now these functions don't look like amazing. They definitely don't look linear by any, they may not be linear by any means. It kind of all depends. You really have to look at, oh, my screen, I forgot to share my screen. I apologize, guys. It's the second time I've done that. All right, I apologize. So if we just, again, all I've done so far is compare look at the inputs and outputs and shown that these two have to be functions, okay? So for the first part of this, we just kind of want to look at evaluating this, okay? So for example 1, so if I want to find g of 3, for example, actually I'm going to use blue for that, sorry. Okay. So if I want to find g of 3, since g we're using blue. So that means that for the input of 3, so I'm going to go up here to my x column, I'll find 3, okay? And I want to tell what the function's output is at 3. Well, the function's output as 3 is -5, so g of 3 is -5. And again, this is just kind of a review of how to read these types of tables, okay? If I want to find f of 2, okay, my input is 2, so I'm going to go over here to 2. Right? And I'm going to evaluate f at 2. So at 2, f equals -8. Okay? Our function is -8. So now when we get to part C, right? When we get to part C, it looks a little bit more complicated because it's saying, well, what's the inverse of 2? Okay? So I know the inverse of f at 2. And you're probably going over here going, well, it's the same thing, right? If I go to x, my input is 2, and it's -8. When we're reading a chart like this, remember, in order for it to be the inverse, what happens? What happens with my x and y's? They flip, right? So when you're reading a table like this, right, since obviously there's no f inverse here, so I'm going to use red for this one, okay? So my input is 2, which means, again, so if we're talking about f inverse, these two have actually switched, okay? Which means that these are now my x's, right? And I'm actually going to get rid of those. And these are now my y's, okay? When they flip. So my input is 2, right? Which means that I got to go to my x's. So now this becomes my input. So this is my input, right? And the output of the inverse should be -2. So essentially you read the chart backwards in this case, if you're trying to use the inverse. Okay? So who can tell me what g inverse of 3 is? Anyone wager a guess? What is g inverse of 3? G inverse of 3. Yeah. Perfect. It's -3. Okay? And the reason why, again, you read this backwards. Okay? So, if I go g inverse of 3, that means that these two have switched places. and now these are my x's and these are still my y's. So now my input is 3, which means my output is -3 for the inverse. Okay? And then for E, who wants to wager a guess of what is F inverse of F of 2? This kind of carries with the two ideas. All right. So I hear one guess is 0. Any others? No. What? -2? Any other guesses? 2? Any other guesses? Okay. It is actually 2. Okay? And here's why. Well, let me go back to I don't know what happened to my and stuff. Okay. So it is actually 2 because, right, so if I think about, well, f of 2, right? What is f of 2? Well, f of 2 is -8, okay? And so then I want to find, so then what we're really doing, is we're finding, okay, well, f inverse then of -8, right? Well, f inverse of -8 is 2, okay? Remember, this kind of goes along the lines of that idea, right? Of if they're inverses, right? F inverse of f of x should equal x, as well as f of f inverse of x will equal x if they are true inverses. Okay? And so this table just kind of exemplifies that. Right? So now what we want to do, right, is we want to find the inverses of each of these functions. So for 2, we're going to do A together, and then I'm going to let you guys do B. All right, then we want to use the graphing calculator, and we want to graph them both on the same plane, okay, on the same set of axes. So then we want to find the domain and range of f and f prime, and then we want to determine if the inverse is a function, right? And if it is, right, great. If it's not, how could we change the domain in order to make it a function? Okay? All right. And that'll make sense in just a bit. So we're going to do x squared minus 1. Okay? So before we actually, we know how to graph x squared minus 1, so why don't we just go ahead and do that first? Okay? So I like graphing. We're going to go f of x is blue. Okay? And then I'm going to also label my graph. So this is 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, -5. And 1, 2, 3, 4, -5. Okay? This is my x, this is my y. So I'm going to graph x squared minus 1. So it's just the graph of x squared. It's just translated down 1 unit. Okay? So I go to the right 1 and up 1, left 1, up 1, go right 2, up 4, go left 2, up 4, right 3, up 9. So it's 1, 2, 3, 1, 2, 7, 8, 9. The same thing on this side. Okay? Again, I'm not the greatest with graphing these guys. I apologize. I'm not an artist. Okay. And so this is our graph of f of x. Okay. And before we go on to the inverse, let's just talk about the domain of f of x. What's the domain of this guy? Who can tell me what the domain of just the original function is? All real numbers, or negative infinity to positive infinity. Okay. What about the range for this function? What? To where? To positive infinity, exactly right. So this one would be, and since it actually touches negative 1, it would be negative 1 to positive infinity. Okay? Now again, we already know that this is a function. Okay? So let's try to graph its inverse. So let's find its inverse first. Okay? Remember, when we find our inverse, the first thing we want to do is we want to write this as y is equal to x squared minus 1. And step 1 has us switch the x's and y's. So this would be x is equal to y squared minus 1. Then I would add 1 over, or then I'm going to solve it right, algebraically. Add 1, add 1. And so I should get, and I'm going to move it up here, should get x plus 1 is equal to y squared. And then I would take the square root of both sides. And so I should be left with y is equal to the square root of x plus 1. Okay? But remember, when we're taking the square root of a square, right, we actually have to include plus or minus. Okay? Plus or minus. So, hold on. I use red for the final, so I'll rewrite this again. Sorry. I just want to leave some space here. So I got y is equal to plus or minus the square root of x plus 1, which means that f inverse of x is equal to plus or minus the square root of x plus 1. Okay? So, let's go ahead and graph this guy. Okay? So, this is a square root function. We have done a cosmic catalog on square roots for functions before, have we not? Yeah. But there's one thing that you have to consider in here. This is essentially kind of 2. So the way that you can think about this is kind of almost piecewise. Okay? This is the same thing as this graphing the square root of x plus 1 and graphing the square root of x, the negative square root of x plus 1. Okay? So, when I graph this, I'm going to graph the square root of x plus 1. Remember, all that this does is shift my graph to the left, my square root graph to the left one. Okay? So my square root graph is going to now start here. Okay, and the square root of 1 is 1. If I move over to the square root of 2 is somewhere in here. Square root of 3 is somewhere in here. Square root of 4 is 2. Square root of 5, 6, 7. Yeah, we can't even go the rest. And so this would be the positive, okay? But we also have to take into account the negative, right? So the negative would look more like this, okay? Essentially, we'd have two kind of pieces, okay? Now let's talk about the domain of this guy. What is the domain of this graph? Remember the x's. What's the domain of this graph? -1 to positive infinity. What about the range? It's already numbers or -infinity to positive infinity. So notice how they switch. Now here's the key question. Is this a function? Is my inverse a function? Yes or no? Thumbs up, hold on. Let's see what thumbs up, thumbs down. Is the f inverse, right? Is it a function? Thumbs up, thumbs down. Perfect. No, it is not a function. Okay? And the reason why, right? So again, just looking at the red graph, right? It does not pass the vertical line test. So as I go from left to right, the blue passes because my graph will only touch the blue in one place. But the red, the second I move past the vertex, essentially, I'm touching the graph in two places, so the red fails. Okay? Even though the blue is a function, it fails. Okay? So, how might we restrict the domain? Oh, shoot. Come back. Come back. How might we restrict the domain, right, in order of the original function in order to make this true? How might we do that? So basically, the question is, if I got rid of, because this minus here, the negative square root of x, if I would have gotten rid of that part down here, right? Sorry, I'm going to shoot. And I just had this function, right? If I just had that, right? The last one would be a function, but the problem is these two wouldn't be inverses, would they? Because remember, the inverse, in order for something to be an inverse, come on. It's like, they have to reflect, if I can get it lined up well enough. They have to reflect along the line y equals x. Okay? And they don't, it's not a perfect reflection. So, what could I do to the blue one, to the original function? Right? How could I change the domain of that in order to make it so that it's inverse, the square root of x plus 1, right? It only includes the positives, right? And it becomes a function. Well, it would work if I got rid of this half, wouldn't it? That would be perfect, wouldn't it? What did I do? What did I do here? What did I erase? I erased all the negative values. Okay? So, if instead for my domain, right? If I instead for my function restriction, right, if I change my domain, right, and said that it's x, the f of x is equal to x squared minus 1 for the domain of 0 to infinity, so only my positive values, let's look at how that would change that. Okay, so if I did that, that would mean that we would always assume that the square root would have to be positive when I did my thing. And so I could get rid of this negative portion. And then if I restrict the domain to 0 to infinity, that would mean the range of this guy would go 0 to infinity. All right, and then it would be a function. Okay. Now I'm gonna put all that stuff back in here when I actually publish the notes. But I just wanted to see why it is the way that it is. Okay. So while I'm kind of pushing this, putting that stuff back together and kind of doing this, I want you to try and work on part B by yourselves. I'm gonna give you about 2 minutes to work on part B, and I'm actually gonna pause the video. So that when you get to this point, you don't have to sit here for 3 and 5 minutes while I'm doing this. Okay.